Now let's look at some other concepts about probability of events and events themselves. Okay, the events can be thought of as mutually exclusive and collectively exhaustive. Okay. For that, we need to understand what each of these concepts means. So events are said to be mutually exclusive if only one of the event can occur in any one given trial. Okay. For example, if the experiment is to roll of a fair die, okay, outcomes being 1, 2, 3 through 6. Okay. Now, if you define an event, say event A is even, right? And then you define another event B is odd. So now event A and B are mutually exclusive because if event A occurs, event B cannot occur. So it cannot have both an even and an odd number phase. So it's something like this. If you have A is even, B is odd, there is nothing common between A and B. And therefore, event A and B are said to be mutually exclusive. Now let's look at another example. Now this time an experiment is drawing one single card at random from a deck of 52 cards. So now suppose if I define an event A as drawing a card numbered 7. So event A is number 7. Now event B, let's now define another event. Event B is draw a heart. Now, so event A is drawing a 7, event B is drawing a heart. Okay, now is event A and B mutually exclusive? So for these two events to be mutually exclusive, one event having occurred means the other cannot occur. But in this case, a 7 can be a heart as well. There are 4 sevens, so and one of those 4 is a heart. So these two events are not mutually exclusive. Okay. So it's like this. So you have A, which is 7, and there are 4 sevens, and this is heart. Now this area that intersects, that's our 7 of heart. So B is all hearts, A is all sevens. Now that is A and B, which is 7 of heart. Now the second concept here is collectively exhaustive. So that means in collection, when you put all the events together, that covers all the possibilities in the sample space. So events are called collectively exhaustive if the list of outcomes included in every possible in all the events covers all the possible outcomes. Now let's look at an example. So our experiment is draw a single card at random from a deck of cards. Okay. Now let's define event A as a face card, event B as red cards. Okay. And we will define one more event C, black cards. Now if these 3 events collectively covers all the possible outcomes in the sample space. So A, B, and C are collectively exhaustive. Now when we put these two concepts together, we get what is called mutually exclusive and collectively exhaustive events. Okay, this is a very important concept that we will be coming back to in Bayes' theorem. So let's look at an example here. Okay, we have an experiment which is roll of a die. Okay. Now we'll define an event, say even. So event A is even. Now event B is odd. So now we know that event A and B are mutually exclusive. You cannot have even in it when the outcome is odd and vice versa. Okay. Now these two events A and B collectively covers all possible outcomes. So both are true. It's mutually exclusive and collectively exhaustive. So we can say A and B are mutually exclusive, collectively exhaustive. Okay, we'll do another example. Draw a single card at random from a deck of cards. Okay. Now the event A is a face card. Okay. Event B is, is a number card. Okay. Now these two events are mutually exclusive because you cannot be a number card as well as at the same time be a face card. Okay. And these two events collectively covers all possible outcomes in the sample space. So once again, these two events are mutually exclusive and collectively exhaustive. One more experiment. One more example, the last one. Once again, let's look at an experiment that is drawing a single card from a random deck of cards. So event A, let's say it's red cards. So event B is black cards. So obviously these two are mutually exclusive and collectively exhaustive.